Okay, thanks. So I think that we all know that when we work on a system, after some time we see that the complexity starts to grow a lot. And I've been for a long time looking for ways to reduce this complexity. But then I realized that that's not something that we can do. After all, we all want our system to do something useful, to solve some real life problems. And these problems are fairly complex on their own. So fighting this complexity associated with the domain is not something that we can do. But the problem is that as the complexity grows, the size of the system grows as well, and we have to deal with that. So on the project I am currently working on, this is the number of modules that I have, and that's excluding the web directory whatsoever. In these modules, this is the number of functions. This is the number of dependencies between the modules, and this is the number of database tables. So there's plenty of stuff, plenty of connections between these things. And when you look at the system, you see this thing. You see a lot of different modules using different database tables, talking to each other in some different ways. And we have to keep these things in our minds to work with that, to understand the system. But the problem is that we physically cannot do that because this is the number of our working memory. The scientists say, based on different experiments, that at any given time we can only fit in our mind 4 to 7 things. So how are we supposed to handle these big systems consisting of multiple elements and connections if we only can think about 4 to 7 things at a time? And I believe that most of the efforts done in software architecture and software design is an attempt to try to solve these issues. And we have a lot of different ways of dealing with this complexity and this size of the system. We have patterns, tools, architectures. In the recent years, you could see a growing popularity of things like event sourcing and CQRS. We saw a lot of movement in the domain-driven design community. And we use patterns like bounded context and aggregates to split the system into all more manageable pieces. We see a lot of people trying to use microservices to separate the system into smaller parts. And when you look at these examples of patterns or techniques, you can see that most of them are all about decomposing a system into more manageable pieces. And this is what I will be talking about, but won't be talking about separating an application into multiple services. I will be talking about using a single monolith application. Sorry, that works. But a single monolithic application with a single Postgres instance, because I believe that once you get the modules right using this approach, you can easily go to microservices, go to event sourcing, but going the other way is kind of tricky. So modular software design. This is not a new idea. It has been talked about, it has been written about for at least 50 years right now. We have been wondering as an industry how to decompose system into modules that are easy to understand and easy to work with. And this is the big idea here, is to take this one big problem that we have and try to separate it into smaller pieces that we can work with without having to fit this enormous number of items into our mind. So in order to do that, we have to split the module into a system, to split this one big problem into smaller subproblems, and then put each subproblem into its own module. And our goal is to make the modules small, make the modules well isolated from the rest of the system, make the system in such a way that we don't introduce a lot of coupling. And when we achieve this, we can understand each piece of the system in isolation. We can reason about each subproblem without having to worry about too much unimportant detail. We can modify some parts of the system, some behaviors, without changing multiple modules. We can test the module in isolation, and we can even replace the module entirely or remove the functionality whatsoever without hopefully breaking something. And the important question is how to do that, because we all know that we are supposed to do this. We should partition our software, but finding the correct criteria to decompose the system can be a bit tricky. So I will be talking about an example project to illustrate a most common way of creating software, of designing the domain. Then I'll show you some problems with that approach, and we will wonder how to extract some pieces to make it more manageable. So imagine that you're working on a job sharing application. So as a user, you have something that needs to be done, but you don't want to do this yourself. So going to our system, you can create a job, and other users who want to earn some money can browse the list of jobs available. They can search the jobs or filter them by some parameters. They can choose the one that they like, start the job, do the job, and earn some money. And this is quite a simple system, right? And we can probably write the basic functionality quite simple and quite fast. And there are many approaches to designing this domain, to writing the system, but I believe that the most common way, and the way that is most often chosen, at least at the beginning, is to start with the data model. So we would need some kind of a job schema where we would have fields like name, description, price, date, time. We have an ID of the user who created the job and ID of the user who is doing the job. We also need to have some code to manage this data. So following the naming conventions of things, we create a job context. We put functions like fetch by ID, search, of course, and functions to change the state of the job. So we have start, accept, cancel, and publish. And it is quite simple right now, but now let's explore what happens when we develop the system, because it's even though it provides the basic functionality, it's far from being perfect. So the first thing we would like to add is to support for slugs. So a slug is this human readable identifier that we use in links to improve both the user experience of the users and to improve the position of our application for the search engines. So again, the most common way of doing so, and I checked all the tutorials that I could find on how to do slugs in Elixir, is to just put another field on the job schema. We put a slug field, we add a unique index to make sure that the slug is unique, and we add another function to fetch the job by its slug. And while it's simple and it's easy, we have a lot of disadvantages that I will go back to. But now let's explore other changes in the behavior, because we would like to require users to pay for the job before we show the job to other users. So a user who creates a job can save the job, but until the payment is done, the job won't be visible in search and other users cannot start the job. So we basically have to add this screen that forces the user to pay, showing them the price. But we also have to modify the existing behavior of the application. We have to keep this extra piece of information to know whether we have made a payment. We need to add another function to store this draft. But we also have to modify the functions that are already written. We have to obviously modify the search function to return only the jobs that have the payment associated with them. But we also have to modify other functions, or at least ensure that they are working correctly, especially the start function. It may not be obvious for many of us, because when you use the user interface, as you should, it won't be visible that the start function has to be modified, because after all, you can't click on a job that you cannot see. But when you go to the terminal and do the request manually, you could start a job that hasn't been paid for. So this means losing money. So it's kind of tricky, especially as the application grows, to keep track of all the changes that we have to make when we introduce a feature like that. And by doing the thing that we did, by modifying the existing functions, we clearly violated the open-closed principle. And while it's commonly associated with the object-oriented programming, it applies as well when designing systems. We don't want to touch existing functions when we add new functionality because we risk making a mistake. We have to make sure that we go through each of the functions to analyze whether the change has to be made or not. We have to write additional tests, and the functions are getting more and more complicated, which is not a desirable thing. So we see that this starts to get bigger, but then we add another feature and another small feature because we want to send a notification to the users. So the idea here is that when you have a job assigned and the job has a start date, you receive a notification saying that the job is starting soon. So to do that, we need to store another piece of information. We need to know if the job has been started and if the notification has already been sent, because we don't want to send notifications for jobs that are already started because they are pointless from the user perspective, and we only want to send notification once. We also need to add another function. So you can see a trend right now. Every new feature that is introduced to the application, every new change in behavior makes the job schema a bit bigger. It makes the job context a little bit bigger. And we have to now think about all of these different things when introducing new features, when making changes. When a new developer goes into a system, he or she has to learn about the things that all of these functions do. But not only that, because we make these things bigger, but we also make them more coupled to the rest of the system. So we have, for example, a payments module that is somehow connected to the data in the jobs table, because, for example, it does a preload on jobs to display them in the view. We have a user context that, for example, would like to display a jobs count for each user. So we have to do a join between the users table and the jobs table. And as we add new features, new pieces of code, we see that they are all somehow connected to jobs. So changing anything in the jobs table requires not only going through the entire job context module, but essentially going through the entire system to analyze if we hadn't introduced any bugs, if we hadn't forgotten about something. And the reason that the problem exists is that we are focused on the data. We are focused on the nouns entities we have here in our system. And in most systems, there are really only few essential nouns that you can list. Here we have a job, a user, a chat, for example. And most of the interesting things that our system do will involve more than one noun. So we have a lot of interactions between them. We have a lot of coupling between the nouns. And changing such a system is a really big challenge. Also, most interesting things are now represented by simple update operations. So this means that things like starting a new job, which is pretty interesting thing from the perspective of this system, is just represented by the update setting the creator contractor ID on the job, which is not a good thing. And unfortunately, we are used to thinking about nouns. We use them in object-oriented programming, which is still the most popular paradigm, even if we don't like it. We use this in databases when we have really limited set of operations, but we have an unlimited set of nouns. So we are quite used to using nouns as a primary design concept. But the problem with them is that nouns are not universal. We are trying so hard to model this thing called a job in our system, but the truth is that a job means something different, depending on the state, depending on who looks at the job. So trying to model this one job schema is going to cause problems. So now, instead of focusing on the data, I would like to focus on behavior and start extracting behavior into small manageable pieces. And the way I I try to design these modules is to ask myself a few questions. And the most important thing is to ask what is the desired outcome. So what should happen when I call this module? So essentially, what is the responsibility of this module? Once I know that, I can think about what data is necessary for this module to fulfill its purpose. And once I know what data do I need, I can think about how should I get this data. And then I have to design the interface, so to decide which pieces of information are essential and should be part of the public API, and what information or decisions should be kept private and encapsulated. So let's now think about extracting slugs and how to do this in a more modular fashion. So we need to have this. We need to be able to access jobs by using this human readable identifier called a slug. And to do that, we only need to know what is the mapping between an ID and a slug. And following the modular design, we are extracting this behavior into a separate module. We can put a separate database table as a private database table for this module when we only keep a slug, an ID, and that's it. We can also provide a simple interface that allows this module to interact with the rest of the system. So the only way we use this module is to call the register slug functions when we want to add a new slug to the system, and then we can fetch the ID by slug and fetch the slug by IDs. So in the controller, we do this. We take whatever the user sends us, the client sends us, put it into the fetch by ID by slug function. It returns the ID of the job, and we pipe it into the job context to fetch the job by ID. We have to do this the other way. So in views, we have to render the slugs for jobs. So we just take a list of jobs, collect their IDs, fetch their slugs, and put a slug on each job. So by creating a simple module with 3 functions, we are not only able to remove a field from here and a function from the job context, but we gain a lot of different benefits because now we focus on behavior, not on the resource. So we can reuse this behavior for other stuff as well. So if we want to support slugs for other resources, for example, for users, we can just reuse the same module. As you saw, we pass the resource name, so we can, for example, pass the user and use the same code for users. Also, changing the rules of how the slugs work is pretty easy as well. So if we want to support multiple slugs for each resource, it is pretty easy to do as well, and we don't have to change many pieces as we would have to do if we just put the slug field on the job. And most importantly for me is that we are resolving slugs at the controller level, which means that there are no slugs in the domain code, which is pretty amazing because this means that we can write the code once and then forget about it entirely. If we put a slug field on the job, we have to remember about it all the time. When we add, for example, subtasks to a job and we want to fetch those, we have to remember to support slugs. And by extracting the slug behavior into another module, we are basically getting that for free because we use only the IDs, which is pretty amazing if you ask me. So we can do the same thing with notifications. So once again, we are thinking about what is the desired outcome. And it's that we should send a notification just before the job is starting. So in order to do this, we need to have an information about whether the job has a contractor assigned, if the job has been started, and we need to know the start date. So we can try to follow the same pattern as we did with slugs and create a module and put a table with upcoming jobs inside this module. But when we think about interface of this module, we can see that it's pretty hard to use. It's not like we can forget about this for forever because we have to remember to call these functions when the job should be added to the queue or removed. So it's not a good interface. It requires a lot of knowledge from the developers, so it's hard to use. So maybe we can do something else. And we can, because we have this job context and we have a search functions. So we can use this as a source of information and only keep this information about which reminders were already sent inside the context. So this makes our code pretty nice because we only need some kind of background job which executes every so often and calls a function. Inside of this function, we fetch the list of jobs which are starting in a given period. We fetch the IDs of the jobs that we already have sent the reminders for, and we call a logic. As you can see, the logic is a simple function which receives all the information through the parameters. Here it is. And iterates through the list of jobs, checks whether the conditions are met, and calls a function. And by doing so, by extracting these simple functions, we've basically isolated the logic from the data source, which means that when working with this module, we can do the thing that we do right now, so use the job context, but we also can switch later if we need to some kind of event stream. We can use a database table, and what's nice, we can use just test code to provide the data. So testing all of different edge cases, if the logic becomes complex, is pretty trivial because you don't have to worry about these complicated setups. So I would say that it's another small success. We are able to remove another field from the job schema. We are able to remove another context. And once again, we have this module that we have written, and we can forget about it, because as long as the search function stays the same, we can be sure that the module just keeps working, which is again pretty amazing, because it frees our memory to worry about something else. So the last feature that we added before was this publishing. So we want to make the user pay for the job before we show it to the users. And this is what the module that we'd like to extract should do. It should publish the job only when the payment is made. But we see a problem because, as you saw, we use the same data model for all of these behaviors related to jobs. So we have this job context that has multiple responsibilities. It is responsible for adding new jobs, for editing existing ones, for when the job is published. It's responsible for searching. It's responsible for managing ongoing jobs, for managing the archive. So there's pretty big pieces of logic there, and we have a lot of responsibilities. So as a result, we have to, with each change, we have to look at all of these functions and analyze if we should make a change there or not. So maybe let's separate the data as well. So let's maybe extract a module responsible only for publishing the jobs. And let's, by the way, change the name because it's not a good name. Let's use something more revealing. And now we can see that we have separate storages. We have one table for job drafts and another table for jobs. And to make sure that the data in the job board context is correct, we can enforce the structure of the parameters at the boundary. So we can have a struct with this enforce keys attribute that verifies, at least tries to verify at the compiler level, if we pass all the different keys. So we now have two modules. One is responsible for controlling the rules of when the job is published. One is responsible for the time for most of the different stuff, but we'll move to that later. But the interface for this new module is really simple. We just have to implement 3 functions that allow us to create a new draft, to get existing ones for each user, and to pay for the job to publish it. So as a result, we are able to remove another field from the job schema, because now all the jobs that are on the job board are published, and we don't care whether they are paid or not. We just display all of them. We are able to remove this one function called create because we now just have publish, and we are able to simplify all of these functions because we now don't have to filter out jobs that aren't paid. We don't have to ensure that we don't start an unpaid job because it's simply not possible. We cannot physically make that mistake because there is no job on the job board that is not available to be taken. And by doing so, by setting this clear boundary between the job board, we made this module much easier to work with. We can now test the behavior in isolation without having to mock payments or anything like that. We have logic that is simpler because there's no this if job dot published or paid, so it's much easier to understand. And we don't risk making any mistakes associated with publishing jobs, so it's quite nice. The job publishing module, on the other hand, is also quite easy to work with because we can change the rules of publishing. So if there are any, for example, special offers, promotions, or discounts, we can control that from this place. It can also be used alongside other modules because we have this strong boundary, and this means that we don't care who calls this job board publish function. We can call this from the job publishing module, but we can also create another module just for admin to post jobs without having to pay for them. We also can just use the test code to test this behavior, which is quite nice because once again, we don't have to do any complicated setup in order to test the behavior of the job board. And we can take one more step because the job board is now not responsible for publishing, but it's still responsible for managing both ongoing jobs and the jobs that are available to be taken by someone. So we can separate it once again and have another module, another database table, which stores only the information necessary in this context. And by doing so, we can simplify the job board even more because now we can remove the contractor ID. We can remove the fields called started because we all know that all the jobs on the job board don't have the contractor, they are not started. So once again, we are able to simplify all of these functions. And at this point, when we also remove the jobs that are finished, we make sure that the search function is pretty simple. It's just a query with the parameters provided by the user. We can get rid of any validation in the start function, in the cancel function. So we make it impossible for us to make any mistakes. So it's pretty amazing as well. So we have seen that we try to isolate the behavior, but we also isolate the important decisions. So we can start with a list of such decisions, things that we are not certain how they will be implemented in the future, how this behavior might change. And in this project, we have questions like, what are the rules for publishing, when the contractor is chosen, and how? And by following these simple patterns of listing the important decisions, listing behaviors, and separating behaviors into separate modules, we can make sure that each decision that we have to make is isolated. So we can change this decision later without having to understand the rest of the system, without having to understand all of these complex interactions between pieces. So to sum up a little bit, we started with this job context that had no clear responsibilities. We started with the job schema that with time grows bigger and bigger. It was hard to understand, it was hard to change, it was quite easy to make a mistake and to introduce bugs that are quite hard to debug. It had this tendency of pulling new behavior So with every new change, every new feature, it grew a lot. And deleting all old features that we no longer need is quite tricky, because we may think about this reminders feature, and it's quite possible that the field started that we used for the reminders feature is used somewhere else in the application. So when we want to just revert the commit that we did for the reminders feature, we break the rest of the system. So it's quite hard to delete old code, and that's why we are often scared of deleting the code. By separating the features into different modules, we make our jobs a little bit easier. We basically can tell pretty easily what each module does. We can, if we want to make some change or to debug some bug, we can easily find a place where this code lives, probably. We do this focusing on the behavior, not on the downs. And as a result, we get smaller modules. We get modules that are easy to change, easy to refactor, easy to understand. They tend to stay small. They have this property of us being able to write them once and then forget about them and just watch them work for the rest of the lifetime of the application. And it's trivial to delete them if we don't need a feature anymore, because they are not highly coupled to the rest of the system. So obviously, this is not a silver bullet, and this approach won't solve all of your problems. It also have a few downsides, at least. Statistics are a little bit higher to do, because now we don't have this single jobs table that we can query pretty easily in Postgres. We have different tables, so doing any stats may be a little bit trickier. Just like reports and admin panels, where we typically want to see everything that is happening in our application. The user interface has to change sometimes, because I shown you the screen with the list of jobs for each user, and this becomes a little bit trickier when we have jobs separated into different tables, because stuff like ordering or pagination is harder when you are working with multiple tables. It is a little bit more work initially. Just like with Slugs, we could introduce a slug for a job in half an hour by adding new field, or we can spend some more time designing a separate module and putting the data there. And in some cases, it may hurt performance, because instead of doing a single database query and letting the database do its job, we have to do some of the things manually inside Elixir, which may be slower, may require more queries. So you can experience some performance issues, but I don't think it's a case for most of the use cases. And that's basically it. I don't see much more downsides. I hope that you tell me in the questions. But this approach is just a mindset. As I told you, it's not a silver bullet. It's just a way of looking at modeling the systems and creating code. It's just a mindset that focuses on behavior, not on the data. And I believe that by doing so, but by organizing the code around behavior and around important decisions, we can make our work a little bit easier. And with that, thank you for coming. My name is Maciej, and if you have any questions, I am happy to take them.
I'll start with a question myself, and then I'll make my way to the back of the room. Why is there a performance hit, in your view? It's something I would disagree strongly with.
In my opinion, it's not an issue. It's an issue I heard a lot from people, because as I've said, in this approach, you sometimes do 2 queries instead of 1, for example, with Slugs. I don't think it's an issue, because in most of the cases, increasing the query time by a few milliseconds, it's not an issue. And I'd also say that by doing so, by applying this lower level of granularity, you can measure the performance much more accurate, and you are able to apply techniques like caching or stuff like that much more efficiently. So performance may be an issue in some cases, but in most cases, I don't believe it's a problem.
No, okay, I agree that in full. I mean, at least from experience, it's your biggest problem is maintainability, and that's what you're trying to address here. It's not speed. You're running on the beam after all. So, okay, we had some questions in the back. There was a question in the back first, yeah, and then I'll come over here. We've got a few minutes for them.
If you take the idea to the extreme, then there will be no extra model left. So,
I mean, you still have to keep some data in the database. And if you have a case when you don't need ecto, that's fine, I'd say. I don't know if it answers your question.
Just to clarify what you said, in the last picture where there was 6 different modules and three of them have that jobs table. Is it the same jobs table or?
No.
Yeah, so the data gets copied each time it's accessed?
Exactly. I think that the good idea, and I use this idea a lot, is to copy the data at the boundary of the module. You parse the data into the form that suits you the most, and you store the data separately. And other modules are not allowed to access the data directly, either by joins or by querying the data.
So basically, as your example was an administration of jobs, it means that probably administration would have the whole attribute set, and the other functionality would build on that.
I mean, it depends, to be honest, because some of the tables might be like proper Postgres tables with columns and things like that, but you also can just put an ID column and a binary column and use Erlang term to binary to store Erlang structs. You can store JSON. So it depends on how much control for the queries you need. If you only need to basically key value store, you can store the Erlang struct, Elixir struct. And if you need some more queries, like for the job board, you obviously need to have a support for quite rich queries. So you would need a full database table.
Hi. In this case, it seems that SEO module will need to search for job in many tables.
Not really, because when you, as we've said, we copy the jobs from one table to another, from one module to another, but the ID stays the same for all the modules. So the SEO module just contains the mapping between the Slug and ID, and it knows nothing about which module is then used.
But how does he know in which table to search?
So the question is, how does he know which table to fetch the data?
This module doesn't know that. You know this at the controller level when you want to fetch the data. So if you are working with the job board, you fetch the data from the job board. If you are working with an ongoing job, you fetch the data from there. But the SEO context knows nothing about that.
Can you explain a bit how this works with umbrella apps and sub apps? Do you have all these job contexts and also the data models and the business logic within the same sub app, or how do you separate them?
I don't have a strong opinion about that. Some time ago, I preferred to work in umbrella apps, but they, in my opinion right now, they don't provide you with so many benefits, and stuff like CI and building this gets a little bit trickier. So I don't know. If you see any benefits, I think it would work perfectly as a separate umbrella apps, but it can be used just in a single application as well. I don't think there's any issue with that.
So my question's about where would you consider using a state machine instead of this type of approach? I mean, fundamentally, using different database tables is a bit like message passing between various states anyway.
I don't know if I understand your question correctly. You're asking when should we use this approach and when should we use a single table that acts as a state machine?
Not a state machine. Not.
Yeah.
Forget the database. Pretend this is just message passing between transient processes.
Okay.
Is that not a re-implementation of a state machine then?
Actually, yeah. But when you are using a state machine and using processes, you have to deal with storing the data anyway. So I do believe that it introduces a lot of complexity, that if you have an experience with OTP, it's fine, but a lot of people don't. And I believe that to be working with Elixir, you don't need all of this OTP stuff, especially at the beginning. So I would say that, yeah, this is the same idea, just implemented differently. But to extend this a little bit, the idea here is to basically make some of the transitions disallowed by separating the data. And state machine is exactly that. So you have a point right here. Yeah.
Okay. First of all, thanks for the talk.
Thank you.
I had the impression that maybe, and well, my question is, would it be reasonable to think about that? All these like different tables for something that is essentially the same data could be like done with database views on a single raw table that would help, for instance, reporting and back office admin, etc. And basically, like for instance, in the SEO part, provide a view where the ID of the view is the Slug, or for instance, the view for the job board will be just a specific select on the raw table, etc. Do you think that this can like have drawbacks in this decoupling?
Yeah, the one drawback I see is that using views give you a little bit more elasticity. So you are using the same database table underneath. So if we have a need to, for example, for one of the modules, switch the storage for, I don't know, performance reasons, or you have such a rich queries that you would like to use, for example, Elasticsearch for something, you now have a little bit more to do. Another thing is that I believe that we as developers need some constraints, and using views is a little bit lighter constraint, so it's easier to cheat. And I prefer not to have a way of cheating, especially when designing a system.
Okay, I know you have quite a few more questions left. We've run out of time. Corner him during the break. We've got a coffee break now until 3:15, so you can continue with questions then. Thank you very much. Yes.
Thank you.